Hello my dear students, I am B S Pandey, your physics lecturer. Today we are in lecture number 24. We are studying in standard 11 laws of motion. Okay my dear students, so look at here, the lecture number 24. It is Newton's laws of motion. My dear students, in last class we have studied about the free body diagram and how to solve some questions we have learned. Today we will solve few more questions that are very interesting. So let me start from the first question. In last lecture, my dear students, we have discussed about the tension, that is a special force. It is the form of force which acts over a string. We have discussed pulley mass system, PMS, and inclined body problems we have studied. So here the first question for today, it is a very simple question I'm taking. The mass M, 2M and M. Alright. Here F. What should be the value of F so that the system remain in equilibrium? This is your question. What should be the value of F so that system remain in equilibrium? And also calculate tension in each string. Tension in each string you have to find. Here you can see we are having the two strings. You have to find the tension in each string. Okay, so let me solve this question. How to solve? My dear students, first we will do the free body diagram. Here the weight, it is mg. Here the weight will be twice mg. Here the weight, it will be mg. Okay, now those two strings were connected. Suppose it is the tension T1. Here again the two strings were connected, so the tension it is T2. Why we have changed the tension, my dear students? Due to change in string, we know that tension will change. Okay, now we are having the three free body diagrams, 1, 2 and 3. And what is the very important? The system is in equilibrium. System is in equilibrium. Okay, one by one we will solve the equation. We will write the equation. For this one, the equation sigma Fy, it is equals to 0 using the Newton first law. If this body is in rest, it should be in rest. It should be remain in rest. So the sigma Fy equals to 0. How many forces are acting, my dear students? In upward direction the force it is T1 and downward direction it is mg. It means that T1 will be balanced by mg. This is the equation 1 for free body diagram 1. Now for free body diagram 2, 1, 2 and then 3. For this one again we can write the sigma Fy, it is how much? 0. Alright. For this body, my dear students, you can see the number of forces that it is acting in upward direction only T2, and the downward direction it is twice mg plus T1. You cannot forget this T1 also. Here T1 is also acting through this thread. Now from equation 1 you can put the value of T1, it is T2 equals to twice mg plus T1, it is mg. Altogether it is thrice mg. T2, equation 2. Now we will solve the third equation for the free body diagram 3. So for this one, the one force it is acting in upward direction F, and the two forces in downward direction it is the mg plus T2. From this equation 2 you can put the value of T2 and it will be F is equals to mg plus T2, it is thrice mg. So altogether it is 4 mg. See the answer. Okay my dear students, one can tell me directly, sir, I can write the 3, 1, m, 2m and m. It is the 4m. Of course, this will have to apply the 4mg to hold this one. Alright, so one by one we have studied here the what should be the tension as well as the force. Now the next question I am giving you, my dear students. Here. Next question we are going to discuss. The next question I am going to give you, you can solve by the Lamy's theorem also. Here a body of mass m. If you will apply your force from here, alright, if you will apply your force from here, a force F, what will happen? This will look like this one. Okay, it will look like this one. If you apply the force F Newton, alright, at so much hard, this makes an angle theta. Okay, so to make this theta angle, what should be the value of force? This is the question. How much force you will apply to maintain this thread at an angle theta? For example, suppose if you are given this m is 10 kg and theta should be 30 degree, how much force you should apply so that this theta becomes 30 degree? Remember, if you will increase the force, here the theta will decrease. It means it will change. So you have to find the force for which this is to be theta. Okay, try to solve this question. My dear students, here we have put a knot and around the knot we know that the tension will be changed. So let me do here the first free body diagram. Here the tension, it will be T1. Here will be the tension again, it is T2. And here it will be the mg. Alright, no more forces are there. So we have done here the free body diagram, system analysis. Suppose this is the point P. This is the point P. Of course, this point P is in equilibrium. Am I right? Yes, this point P is in equilibrium. Now, we will study one by one all the forces along different axes. Suppose this is y and x axis. Now my dear students, as you can see, this force is along x-axis. This T1 is along y-axis. Very good. This T1 is along y-axis. This mg along y-axis. But we cannot see this T at T2 at any axis. So we will break the component of this force along x and y axis. If this is theta, this will be the theta. This T2 will have the two component. One, it is T2 cos theta and it is T2 sin theta. Okay, now let me draw this again for the point P. We're having the forces in this direction. It is one force, it is F, and it is T2 cos theta. Here it is T2 sin theta, and here T1. Alright, and for this body it is T1 and downward it is mg. Now for this point P and for this body you can apply the equation one by one. Okay, for this point P, sigma Fy should be 0 and sigma Fx should be also 0. Am I right? Yes. If sigma Fy 0, it means this T2 sin theta will be balanced by T1. Alright. And this F will be balanced by T2 cos theta. Am I right? We have to find what? We have to find here the force F. The two equation we got. From this body, we can write T1 will be balanced by mg. Now put the value of T1 over here. You will have the value of T2. Then you will value the when then you will put the value of T2 in this equation 2, then you will have the value of F. I hope you understand. Here, putting the value or dividing this one, you can write T1 by F is equals to tan theta. Alright, so F is equals to T1 by tan theta, or T1 it is mg by tan theta. If you have to find the angle, my dear students, if you have to find the angle, suppose here the 10 Newton we have given, then what will be the angle? Then you can find the angle. Any quantity, if you have been asked, you can solve. What you have to actually think, you have to think for the question how to solve. It is of mechanics. You have to solve the mechanics problem with the SAFI, and we have discussed here the free body diagram and the equation writing properly along with the proper direction of the axis fixation. Now let me rub this one. Next question. We are in the section of numerical solving. One more question. Okay, this is your homework, my dear students. I am giving you. M, suppose this is 53 degree, 37 degree, sorry, I think it is 37 degree, 53 degree, alright, and M is 10 kg. Find T1, T2 and T3. Okay, you have to find T1, T2 and T3. Okay, alright, this is the question. Now, there are a number of questions, my dear students, we can solve. The question, I am having the question of pulley also, but before that, let we study here the Newton second law, and to study the Newton second law, we need the concept of momentum. So, give the heading, linear momentum. We represent with the symbol P. You have been studied. You have been studying, my dear students, in standard 9. Okay. What is the linear momentum? As it is the mathematical things, and it can be represented by the product, or it can be explained with the product of mass and velocity. If you are having a body of mass m and changing its position, if it is moving with the velocity v, then you can say the momentum, it is mass into velocity, and the direction of momentum must be in the direction of velocity acquired by the body. Actually, what this momentum measure? So this momentum measure the change in action of the body. Actually, all right, change in inertia of the body. It measure by the momentum. It is the linear momentum. It is simply the product of mass and velocity, nothing else. Okay. Using this particular momentum, if any particle is moving with the constant velocity, then it will have the constant momentum, and it is the mv. Remember, to disturb this momentum, we require to apply the unbalanced force over the body, and the unbalanced force that will apply, it will change the momentum. Actually, these both are correlated to each other, and it was well explained by Newton in his second law of motion. So we can solve the number of questions using this momentum, but that will be the loss of time, because you have to study very simple questions in this particular section, my dear students. Give the heading Newton's second law of motion. Newton's second law of motion. So this is nothing but the rate change. The force applied, that is the unbalanced force experienced by any body or the applied on any body, it is directly proportional to the rate change of momentum. How much the momentum has been changed of the body and in which time this momentum has been changed. If this amount of the momentum you are changing taking the very last time, it means the force that you will study and the momentum the same you will change in the very small interval of time, and that in this case the force, both the force will change. If you are pushing your friend in quickly applying the same momentum like this way, and if you are pushing with the same momentum your friend like this way, the changing the time you will change, you will have to change the amount, that is the force. According to Newton's second law, it is the rate change of the force. The force is directly proportional to the rate change of momentum. The rate change of momentum. In SI unit we find, or according to this is the experimental, this constant will be the 1 and it is dP over dt. Alright, it is dP over dt. So remember, if the momentum decided by the direction of velocity, then you can find the direction of force as well. Okay, the direction of force. But actually the force act on the body, it is totally decided by the acceleration. Remember, because somewhere if we will go to this change in velocity, the rate change in velocity will reach to the acceleration. Okay, here we can write this equation as suppose the same, here the mass of the body is m and it is moving with the velocity v in time t, this velocity being changed. If we are talking about the change in momentum, my dear student, this p is nothing but the m and v. We know that mass cannot be changed. If you are moving by changing your velocity, you cannot change your mass. If you are of 50 kg, you are moving with 10 meter per second. By moving with the 15 meter per second, your mass will not change. We are studying in the classical mechanics. Okay, so in Newtonian frame, the mass is not going to be changed. Einstein have studied that if any particle moving with a very high speed, the mass will change, and that is the quantum physics. Here we are in Newtonian mechanics, that is the classical mechanics. Here the mass will not change. The body is moving with some velocity. If velocity changes, the mass is not going to be changed. So to give the change in this momentum, we need to change the velocity. Here F, it is equals to d, P can be taken as m into v over dt. Here the m can be taken out, and dv by dt in mechanics, kinematics you have studied. This is dv by dt, the rate change of velocity, to the acceleration, nothing else. So the F is equals to ma you are studying. And remember, this is the net force acting on the body. This is the net force. And this net force, that is the unbalanced force acting on the body to change the velocity and to here impart the acceleration. Remember. So you can write, if any body it is moving along the x-axis by changing its velocity, that is with an acceleration ax along the x-axis, if it is having the mass m, then you can write the sigma fx equals to max. Remember, in similar way, along the y-axis it will be sigma fy, it is may, and sigma fz is equals to maz. Okay, my dear students. So these are the very important equation you have to write. Remember, these are the equation will apply if the body having some velocity, having some acceleration. Okay, and that velocity is changing. Okay, my dear students. Okay, on the basis of this particular equation, we will solve few more questions. But before that, we are going to solve few more questions on the basis of equilibrium portion. Let us solve few more questions of equilibrium, student. Okay, then we'll move for the next type of question. Here the question: the two blocks are kept on an inclined plane of 37-degree inclination, m to m. Here, how much force we require to make the system in equilibrium? Remember, if we will remove this force, what will happen? The system will fall down. Okay, it will move down, but we have to find the force required to make the system in equilibrium. The first and second, the first you have to find the force, and the second you have to find the tension in this string. Okay, so how we will solve this type of question? Look at here, my dear students. As we have discussed, first we have to make here the plus for the free body diagram. Here the M and theta, we know that we must represent the theta with the y-axis. Here theta, suppose it is the 37 degree. We have noted here the theta 37 degree we will use. Okay, mg cos theta and here mg sin theta. Normal. Here we break the string, so there will be the tension in both the string. Okay, now it is twice mg, so this is theta twice mg cos theta, and this will be the twice mg sin theta. I hope you understand. Here m dash, because both the body having the same different mass, so we will use here the different normal reaction. Okay, my dear students. Now here you can use another tension, suppose it is T dash. Now it's time to write the equation, but before that, as we know that we have to apply the psi, so we are going to put here the axis. Remember, in this case of inclined plane, you must give the axis or fix the axis perpendicular, that is over the plane. So this is the positive axis, y and x is the positive axis. Meaning of this positive, my dear students, I am using this quadrant, this axis and this axis. It means this quadrant as positive, and we can take any one as positive. Okay, now solve. This is the free body diagram 1 and 2. FBD1, my dear students, we can write here how many forces are acting downward and how many forces are acting upward. You have to see only, nothing more than. Okay, here mg sin theta is balancing T. Alright, T is equals to mg sin theta, and we know that the value of theta, so we can write here it is T is equals to m10, g it is 10, 100, and sin 37 we can write here 37 degree. Sin 37 3/5. Altogether how much it is? 60 Newton. Okay, keep this value. Now we got it is over the sigma fx equals to 0. Now sigma fy equals to 0, my dear students, it will give you the n balanced by mg cos theta. N equals to mg cos 37. So it is 100, mg will be 100, m10, g10, and sin 30 cos 37 it is 4/5. Okay, so it is 80 Newton. You can keep this normal also. Now for the FBD2, we know that sigma fx equals to 0. Now here the total forces acting downward, it is T plus 2 mg sin 37. Here the T plus 2 mg sin 37, and it is balanced by T dash. Okay, so here the T dash will be T, we have been calculated, is the 60, we can add plus 2 mg, it is the 2 times 100, 100 it is mg. Okay, now sin 37 it is 3/5. Alright, so it is 120 plus 60, it is 180 T dash Newton. This is another value. Now sigma fy, it is n dash will be balanced by twice mg cos 37. It is n dash is equals to twice mg cos 37. So it is twice 100 times 4/5. (160 Newton). This is the value of n dash. Okay, my dear students. Now we have calculated all the value here. Now this force for pulley we can write here, let me write, for pulley we can write, you can see this T dash is balanced by F. There is no any force, because if you will break here you will again write T dash and T dash, and this T dash is equals to F. So T dash equals to F, which is equals to T dash 180 Newton. Okay, my dear students. So the question was how much force required to make the system is in equilibrium. So the answer is, it is how much? A 180 Newton, and the tension in each string. Here we got the tension in this string, it is the same as the T dash 180 Newton, and in this string it is T. Remember students, these questions are very fundamental. You have to just be careful, because on the basis of this type of question you will be able to solve the questions of constant body problem, and that is very important. Okay, my dear students. Okay, let me solve few more questions so that we get some more energy to solve this type of question and more concepts. Okay. Okay, one more question. Okay, let me give this particular question, my dear students, as a homework. All right, you should try this question to solve. How much force required to make the system in equilibrium? It is 53 degree. All right, it is M 2M. And also find tension in string. Tension in string and force. The two things you have to find: tension in string and the force. All right. Here the value of M, it is 10 kg. All right. This is your homework. Now, I don't remember the homework, my dear students. So I've given you the number. Forget it. Now the next question. Let me solve this question. This is another important question of pulley mass system. One more question of inclined body, as I'm getting, as it is coming in my mind. This is 53 degree and this is 37 degree. It is 2M and it is M F. Okay, let me grab this one. M, it is 10 kg. Now listen carefully this question, my dear students. Here the string going over the pulley, and in this case the system might move downward. Okay, so you have to apply the force somewhere. Either you have to apply the force from this M, or you have to apply the force from 2M. Now the question is, how much force and from where should be applied to make the system in equilibrium? Okay, how much force, F, how much and where? Okay, and the second one, find tension. The first and second question, tension in string, you have to find. Okay, so kindly note down this question, my dear student. Now next question. Another question, it is, what should be the value of, this is the m dash, okay, this is m dash. For m dash should be what, so that system remain in equilibrium. This is the pulley, I'm sorry. For system in remain in equilibrium, and also find tension. Okay, tension in each string. Okay, so let me solve this question, and this is a very important question I have given here. Look at here, my dear students. The first will draw the forces. Here the 3 mg. As I told you, to start making free body diagram and represent the weight. Remember students, I used to remember the representation of weight. Why? So that not even a single force I miss to write. If you will miss to write any of single of the force, you will not get the correct answer. So the 3 mg here, connection should be removed, free body diagram. Here the m2 mg, here the 3 mg, 2 mg. Now here it is mg and it is n dash. Now here m dash g, this should be the theta, okay, m dash g cos theta, here m dash g sin theta, it is n. Now tension, my dear students, here tension it is T1, here the tension it is T2, here the tension it is T2. Why T2? Because this is the same string. Here the tension it is T3, and here again the tension is T3. Why? The string is same. Now we have done all the forces. We have done with all the forces. Now our duty is to write the equations. Okay, my dear students. So how we'll write the equation? Look at here carefully. For this body, we will fix the axis like this way. Remember students, in one question, you can suppose more than one axis fixation. As here, I am using this one, the axis fixation. Here, I will use the axis fixation, positive one, this way. And here, for all the bodies, I will use the axis fixation this way. Okay. So, in one question, you can suppose the axis fixation in any way. Now, my dear student, but here for the equilibrium problem, suppose the free body diagram 1, it is 2, this is the free body diagram 3, and this is the 4. Free body diagram 1. So, okay, sigma fx equals to 0, 1, this one. T3, it is balanced by m dash g sine 37, am I right? Yes, and over the sigma fy equals to 0, it is n is equals to m dash g cos 37 degree. FBD1 completed. Now FBD2. Sigma fx equals to 0. Here for this free body diagram, you can see the T2 is balanced by T3. T2 is equals to T3, and from here you can write this T3 as the m dash g sine 37 degree, and sigma fy will give you, which is 0, it will give you n dash is equals to mg. Here the free body diagram we have done. Now free body diagram 3. For 3 you can write T2 sigma fx equals to, sorry, the fy, we don't have any force over the x-axis. Here the fy, it is T2 is balanced by twice mg plus T1. Okay, you can see. And FBD3, 4, you can write again sigma fy equals to 0, and here the T1 is balanced by thrice mg. Okay, now you can put the value of T1 here in this equation, and you will get T2 is equals to twice mg plus T1 is thrice mg, altogether 5 times mg. Okay, we got one value. Now we'll put the value of T2 here in this equation. You can see the T2 equals to T3, so the T3 is equals to 5 mg again. Okay, and T3 it is equals to the m dash g sine 37. So you will put this value in this equation and you will have T3, that is the 5 mg, is equals to m dash g sine 37. So this g will be cancelled out, and m dash it is 5m over sine 37. This is the answer. And it was asked to find the value of T1, T2 and T3. So from this equation you can find the value of T1, T2 and T3. Okay, my dear students. So in this way you have to solve the question. One more question using this particular concept I am giving you of pulley mass system. Let me rub this one. Now I am giving you here the perfect pulley, only the pulley mass system, and might be we have solved. This is your homework. Might be I have discussed this type of question. Here this is the value of mass m, and the m it is 10 kg. Okay, let me write it is 30 kg. Okay, and here through this pulley a monkey is hanging. By pulling this rope. Okay, you have to find the mass of monkey so that the system remain in equilibrium. You have to find the mass of this monkey so that system remain in equilibrium. Here the m is equals to 30 kg. All the pulleys are frictionless and massless. Okay, here from this pulley one string is attached. Here the one string it is goes over this pulley and then to this pulley P2 and comes to the here the pulley P1, and this is the pulley P2. Okay, my dear students, what you have to find? Mass of the monkey so that the system remain in equilibrium. And second thing, you have to find the tension in each string. Here in this string, in this string, in this string. Okay, you have to find. And the third thing, you have to find the net force on ceiling. Net force on ceiling. The second, mass of monkey. Third, tension in each strings. Alright, so this is your homework, my dear students. Kindly solve this question. This is all about today's lecture, my dear students. Thank you very much.